Here we have a SAT math problem. Okay, let's go to the question. If fifth root of a to the power of 6 times fifth root of a to the fourth power divided by cube root of a square equals to a to the power of n for all values of a, what is the value of n? Okay, in the given equation, we have to solve for n. Okay, now let me take the given equation as it is. That is fifth root of a to the sixth power times fifth root of a to the fourth power divided by cube root of a square equals to a to the power of n. Okay, here in numerator, we have two like radicals multiplied because the index of this radical is 5, the index of this radical is also 5. So whenever two like radicals are multiplied, what we can do is that we can take the radical once and we have to multiply the stuff inside the radical. That is, we can take the radical with index of 5 once and let's multiply the stuff we have inside the radicals. That is a to the sixth power times a to the fourth power divided by cube root of a square equals to a to the power of n. Okay, here inside the radical over here, two powers are multiplied with the same base, that is a. Whenever two powers are multiplied with the same base, what we can do is we can take the base once and we have to add the exponents, that is the product rule of exponents. Okay, now let me write the radical with index 5. Now let me take the base once and now we can add the two exponents of 6 and 4, then I'm getting 10 divided by cube root of a square equals to a to the power of n. Here on the left side over here, we can write both the radicals as exponents. Whenever I want to write a radical as an exponent, the exponent will be a fraction with numerator 1 and the denominator must be the index of the radical. Okay, now let me take this radical, particularly the stuff inside the radical, that is a to the power of 10. And now we can write this radical as an exponent, then the exponent will be a fraction with numerator 1 and the denominator has to be the index of the radical, that is 5. So the same thing we can do for this one, that is we can write the stuff inside the radical, that is a square. Now the exponent has to be a fraction with numerator 1, the denominator has to be the index of the radical, that is 3. Now we can write the stuff on the right side as it is, that is a to the nth power. Okay, here we have base a and we have exponent 10 and for this complete stuff we have the exponent 1 over 5. Whenever we have two exponents like this, what we can do is we can multiply the two exponents using the power of a power rule. Then we get a to the power of 10 times 1 over 5. So the same thing we can do over here, that is a to the power of 2 times 1 over 3 equals to a to the power of n. Okay, here 5 goes into 5 one times and 5 goes into 10 two times. We get a square in numerator. In denominator, when I multiply this 2 and 1 over 3, I'm getting 2 over 3. That is, I'm getting a to the power of 2 over 3 equals to a to the power of n. Okay, here we divide two terms with the same base. Whenever we divide two powers with the same base, what we can do is we can take the base once and we have to subtract the exponents using the quotient rule of exponents. So then we get 2 negative 2 over 3 equals to a to the power of n. Okay, here we do subtraction between an integer and a fraction. Whenever I want to do addition or subtraction between an integer and a fraction, I have to multiply the integer by the denominator of the fraction. Once I'm done with the multiplication, I can take this denominator as a common denominator. So 2 times 3 is 6, that is 6 negative 2. Since we have multiplied this integer 2 by this denominator 3, now we can take this 3 as a common denominator equals to a to the power of n. Okay, a to the power of 6 negative 2 is 4. That is, we get 4 over 3 as an exponent over here. On the right side, we have a to the power of n. Okay, here two powers are equal with the same base. Whenever two powers are equal with the same base, what we can do is we can equate the exponents. When I equate the exponents, I'm getting 4 over 3 equals to n. Okay, here I got the value of n. The value of n is 4 over 3 and we find this 4 over 3 in answer choice B. The correct answer choice for this question is B.